What?
I have it here somewhere.
We did 96. So what I'm going to do is 102. This is on 10-1. It's 4 s minus 2, the quantity squared equals 36. Now this particular problem, if you were doing it and you didn't just recognize that you could do it by completing the square, you could expand it out and it would be factorable by trial and error. But if you by some chance recognized that that 4 and that s minus 2 squared on the left-hand side was a square that you could take the square root of, then you could shorten your problem solution time. And I'm going to assume that you are all smart enough to recognize that you have seen that you can either do one of two things. You can either take that problem as it is, or you could take the problem and divide both sides by 4 and get s minus 2 squared equals, and 4 into 36 is 9, right? That you could do one of those two things. You don't want to hazard a guess. If you were to recognize it, which one would you probably do? Left one or the right one? Okay, the right one. Now, if you see that and you say, I can use the square root principle. So I'm going to do the square root of this side principle, and then do plus or minus the square root on this side. And then what I'm going to do, this is s minus 2, and this is plus or minus 3. And then that is s is equal to 2 plus or minus 3. And I've got my answer, right? That quickly. If you didn't recognize it and you thought you had to expand it, I'm just going to whip through it. You may, hopefully you would see that you have s minus 2, the quantity squared, equals 9. Then you'd expand the right-hand side and you go s squared minus 4s plus 4 equals 9. Then you'd get the 9 by its over minus 5. And then you'd say, well, it's going to have to be, you know, it's a trial and error factoring, if you recognize that. And you'd say this is s plus 1 and s minus 5, and therefore s equals a minus 1 or s equals 5. Now, I've done it pretty quickly, but that's a lot longer problem if you just are alert to what it can be. But it could be solved under the methods that we've learned so far. It's just that this thing here, notice that when you go 2 plus 3, it's 5. And when you go 2 minus 3, it's a minus 1. You get the answers. And it's a real quick way. Sometimes it's the only way you can do it, this method is. And sometimes it's fast. Sometimes it's slower. You just add it to your toolbox of things that you have to solve problems, and then you utilize it appropriately. Now, do you think you need any of those problems? Have we looked at enough of that kind of problem? Because we're going to use this information in that C part of that section to do 10-2, because it's an intro to 10-2. So I'm going to do 10-2. I'm going to do these problems. First one I'm going to show you 4, and I'm going to show you a problem that you would never use completing the square on. I would hope you would never. That if you were given this problem right over here, you could go through all that stuff in your head about descending order, leading term, positive zero by itself, it's not a special case. You would know that what? This thing factors which way? Y plus 5 and y plus 1. Wouldn't you just be able to look at it and see that that's what it is? And y is equal to minus 5 or y equals 1? I mean, at this point, after doing this many problems, I would think that you'd probably just be able to look at it and say that's what it is. Now, what I want to do is this is a problem that you would never do completing the square, but I want to show you the completing the square on it, because it's a simple problem, and how you do it. So this is how you do this problem using completing the square. The first thing you do is move your constant term over to the right. That's the first thing you do. The second thing you do is why the name is completing the square. The left-hand side, you would complete the square. And if you remember that the middle term on a squared problem, if you had y, well, let's see, in a formulation, if you have a plus b, the quantity squares, it's the first term squared plus 2 times the product of the first times the second plus the second term squared. Well, to find out what this thing is, it's the first term, and it's 2b is the middle term. So that 6 is twice as big as what you're going to add over here, squared. So you take half of the 6 is 3, and it's a positive 3, and you put a 3 in there, and you have just completed the square. That makes the left-hand side y plus 3, the quantity squared. You've made it that. Now, because I added this to the left to balance the equation, what do I have to do to the right? Add the same thing. So then my right-hand side becomes a negative 5 plus 9, which is plus 4. So I have a complete square on the left, and I have some other terms on the right. Now what I have to do with that, I'm just going to rewrite this. I'm not going to always do it this way. I've set it up as a complete square on the left so that I can take the principal square root and then get on the left y minus 3. Now on the right, you do plus or minus the square root. And that will get you plus or minus 2. Now what you want to do is you want to take that minus 3 on the left, put it over on the right. So you add the 3 and plus or minus 2. Now don't add the 3 to the 2 and get plus or minus 5. That would be wrong. Now notice you have two answers. One answer is 3 plus 2, which is 5. And the other answer is 3 minus 2, which is 1, right? Notice I did this wrong. What did I do? I got my signs backwards. Three. How did my signs go backwards?
Was it when you did the square root? Put it y minus 6 there, and it's going to be it.
That's interesting. I got minus here. Oh, where in the world is that? 6. Oh, right here it is. Do you see this right here? No? Yeah, that was supposed to be a plus. So then this is a minus. There you go. This is both minuses. Eesh. So now then, this is a minus 1 here. And a minus 5. Ah. Is that what you saw? Yeah. Terrible example. Anyway, you can do them either way, but you wouldn't do it that second way I did it. So let's do 10. And rather than s, I'm going to do x squared plus 6x minus 1. So if you did the algorithm, this is because you would not know that you would have to complete the square until you went through it, or you recognized it was. You'd say it's descending order leading to a positive, no common factor. It's a trinomial, not a special case, and you can't factor it by trial and error, right? You cannot factor it by trial and error. Then you would say, I have to use completing the square. What's the first step? Yeah, move the minus sign over to the minus 1 over to the right as a plus 1. So this is the first step you do. Now the next thing you do is what? Half of the 6, which is 3, square it and add it to both sides. It's a plus 3. Now then the left-hand side is a complete square. X plus 3, the quantity squared, equals, and on the right, that's 10, isn't it? It's 1 plus 9. Normally I wouldn't rewrite that. But I'll do it just, you do the principal square root on the left, plus or minus the square root on the right. This makes the left-hand side x plus 3. Does everyone understand why? If it was x plus 3 squared, you take the square root of it, then it's just x plus 3. Equals plus or minus the square root of 10. Then you take that 3 over to the other side as a negative. Negative 3 plus or minus the square root of 10. And that would be your answer. Now, in all of these problems, if you use your calculator and it says square root of a number and you put it in the calculator and you give me a decimal, I'll take all the points. I do not want to see decimals. Now, you know, if you have something like square root of 27, I want you to write that as, you know, that's 9 times 3. I'm using 9 times 3 because 9 you can take the square root of, right? And I want that as 3 square root of 3. I do not want a decimal. If you put that 27 in, push your square root button and give me a decimal, I will take all the points away. Because this is what I want. That's accurate. You put that decimal in and you round it, that's rounding. It's not accurate. So, just a warning. Be judicious in your use of your calculator. 16. Rather than b, I'm going to go x squared plus 7x minus 44 equals 0. Now that thing, you can see that you would be all the way down to what? It's not a special case. And you would say, can I get this thing by trial and error? So you would do x, and you'd say plus and minus, and then you would say, well, it's got to be a difference. That 7 is a difference. 1 and 44, not there. 2 and 22, not there. 4 and 11, and you'd say the difference is 7. There it is, right? The 11 has got to be positive, and the 4 is negative. So would you do completing the square on that one? No. You would do it this way. And then you'd say x is equal to minus 11, or x is equal to 4. So when I give you problems, I'm going to be really careful that I give you problems that you have to do completing the square, because I would expect you not to do completing the square on that. If you did, I'm not going to take off if you get the right answer, but it's going to take you a lot longer doing the test than it needs to. So you saw that problem, you'd say descending order, leading term positive, no common factor, trinomial, not a special case. You would try trial and error. Can you do it by trial and error? No, you couldn't. So then you can do it by completing the square. So what's the first step in completing the square? Okay, you're going to have move the 7 over to the right. Then the next step is what? Add half the middle term squared. So what's half of the middle term? With the sign. What? Minus 1 is the middle term, so half of it. Negative 1/2. Right? It's a negative 1/2. Now what do we have to do on the right? Add that same thing. So now on the left-hand side, we have made this a complete square. U minus 1/2 quantity squared. Now on the right, I'm going to go over here and try to calculate what this is. This is 7 plus 1/4, right? Then we'd have to do a 4 over 4, right? To get a common denominator. 4 times 7 would be a 28, plus 1 in the numerator, all over 4. So this is going to be what? 29 over 4.
Should be 70 minus 1.
No, because you square a negative 1/2. Square the negative is positive, right? Nice try. Now, I'm not going to rewrite that. I'm going to take the principal square root on the left, plus or minus the square root on the right. The left is going to be what? U minus 1/2. Now the right, I'm going to do a little bit. This is plus or minus the square root of the numerator over the square root of the denominator. Now the numerator, you cannot take anything out of that 29, but the square root of 4 is 2, right? So my right-hand side is the square root of 29 all over 2. Now I got to get u by itself, so I'm going to add 1/2. 1/2 plus or minus square root of 29 all over 2. Now wherever I'm doing completing the square, you could get the same thing by using the quadratic equation. I'm going to give you a little bit of a sell job on learning completing the square. You can use quadratic formula or completing the square in the problems that you have here, but in college algebra, you're going to be asked to find the center of a circle and the radius. Quadratic equation will do you no good. You'll have to know how to complete the square. You'll be asked to find the vertex, that is the low point of a parabola, and the axis of symmetry. Quadratic equation will do you no good. Completing the square is what you have to use. There's many problems in college algebra that you will have to use quadratic, or completing the square, and quadratic equation will not apply. The quadratic equation is very simple but has very simple uses. The completing the square is very robust, and it's used in a lot of places to solve things. And I would suggest you practice using completing the square. Now, I'm sure some people who know quadratic equation will resort to doing it and say, I don't have to learn all that stuff. Well, if you want to believe that, go right ahead. Enjoy your life, your pleasant things that you're thinking in your head. X squared equals 2x minus 17. So what, if you saw this problem, what would you do first? Okay, you'd get 0 by itself, wouldn't you? I mean, you would not know that it's a complete square problem. So you would probably just get 0 by itself, and you would neglect all the stuff that you do because you know that you're at the point where you've got to determine, is this a special case, which it is not, and then you'd have to figure out, is it a trial and error problem? And can you do that by trial and error? And you'd say no. So then you're going to have to use what? Completing the square. So you move the 17 over to the constant term over. Now what are you going to do?
I have 2.
Half of minus 2.
Yeah, minus.
And what is that going to be? Half of minus 2 is negative 1, and then you square it, right? And that's what you have to do over here. So what is the left-hand side? X minus 1, the quantity squared. The right-hand side is actually going to be what? Negative 16, isn't that right? It's going to be minus 17 plus, when you square minus 1, it's a plus 1. So it's going to be a minus 16. I'll rewrite this thing. Now you take the square root of the left plus or minus the square root of the right. You remember what you do when you have a negative sign under a square root? Can you recall that? Well, I'll just show you. Plus or minus, and this is the square root of minus 1 times 16, right? The minus 16 can be written as a minus 1. And this can be written as plus or minus the square root of a minus 1 times the square root of 16. The square root of the product is the product of the square root. Now, this is plus or minus. The 16 square root is 4. But what's the square root of minus 1? I. Remember, I told you that's the complex, that's the imaginary number, part of the complex number system. Now, normally you don't say I is 4, you say 4I. So now, this thing turns out to be x minus 1, right, when you take the square root principle. The plus or minus minus 16 is plus or minus 4i. Is that good? Now what you do is you got to get x by itself, so you add the 1. Now when you add that 1, be sure that you do not add it to the 4. Don't get this kind of a problem. And add that 1 to the 4 and get 5i. It's not correct. It's got to be this way. Are you good with that? $28. So let's look at 34. R squared 3r minus 1. When you see that problem, what's the first thing you're going to do? Move everything left, right? R squared minus 3r plus 1, and you would examine that. Well, probably what you'd say, well, that's a trial and error problem, because it's actually, you would check it for a special case, because r is squared and 1 is actually 1 squared, right? That, if it was a special case, that middle term would have to be 2, and it's not. Then you'd say, well, I can't do it special case. Can I do it by trial and error? And you can't do it by trial and error either, can you? 2 numbers times itself is 1, whose sum is 3, don't work. So you say, well, this is a completing the square problem, and you move the 1 over to the other side, right? Now what's the next step? You add what? And it's going to be squared. Which is, no, don't use decimals. 1.5. No, don't use it. Write it as an improper fraction. Okay, write it as an improper fraction. So what would it be improper fraction? What's it? 3/2, negative 3/2. Right? Half of minus 3, 3/2.
Oh, okay.
Yeah.
I thought you were meaning what's the square root sign.
No, no, yeah. And then what you do is over here you go plus a minus 3/2. The other things that you do, this is squared. The other things that you were doing would be okay and acceptable in a lot of places, but here it just doesn't lend itself to doing what we want to do. So now the left-hand side is going to be what? R minus 3/2. The quantity squared, correct? We made it into that. And then the right-hand side, we're going to have to fool with this thing a little bit. Negative 1 plus 9/4, right? Then we're going to have to go 4 over 4 here. So we have a minus 4 plus 9 in the numerator, which is going to be what? 5 over 4. Is that right? So this is 5 over 4. Now we're ready to take the principal square root on the left, plus or minus the square root on the right. That is r minus 3/2 equals on the right-hand side. Do you see that? This is plus or minus the square root of 5 over the square root of 4, which is plus or minus the square root of 5 over 2, right? So that's what I'm going to write here. Then I bring that 3 halves over. Now, if you people that know how to use the quadratic equation, what you would get as an answer is r is equal to 3 plus or minus the square root of 5 over 2. Is that the same as that thing?
Yeah.
Yeah. This is the way it would show up when you use the quadratic. This is the way it shows up when you use completing the square. Yeah.
Wait, how did the 5 over 4 to the 5 over 2? I didn't catch that in the last slide.
Right over here. See, this becomes the square root of 5 over the square root of 4.
Oh, okay, yeah.
Okay.
Yep.
I'm probably going too fast. All right. Let's look at 46. Now I want to use x rather than s. So that's 8x minus 11 equals x minus 4 times x minus 2. First of all, did I have that written up there correctly? Now, what's the first thing you're going to do with this thing? Expand it.
Yeah.
Expand it so you get 0 by itself, aren't you? So you want to expand that right-hand side. 8x minus 11. Then you'd go x squared, and be 4x, minus 4x minus 2x is a minus 6x. And then plus 8, right? Is that right? So you can understand that now. There was a while back, I guess, if you, depending on what your knowledge base was coming in, you couldn't have done that before, could you? Right? I would hope you'd say right. You've learned something. Okay. Now we're going to get 0 by itself. So I'm going to go 0 left, x squared. That 8x is going over negative, right? 14 minus 14x. That 11 is going over positive, plus 19. Is that right? Now you look at that and you'd say, well, it's trinomial, not a special case. You know, I'm assuming that all those other things have flown through your head. 0 by itself, descending order, leading term, positive, no common factor. Be sure that you don't go so quickly that you miss leading common factor. Because if there's a common factor and you miss it, you will not, you'll scratch your head on trying to factor. But anyway, it's not a special case trinomial. And will it factor by trial and error? No. So this is a completing the square problem. Now I'm gonna do everything on the left because my variables, so I'm going to think about it that way. So the first thing I'm going to do is take that constant term over to the right. Correct? Now then, what's the next thing? I add.
That's a quick question. If it was like, if there was common factors, where would you put like the common? You take out of everything. Where do you put that?
Okay, you take the common factor out, and then what you would do is you would, if you had a common factor, you would have something here that would be, you know, like, I don't know, if it were a constant term like 2, 3, 4, 5, 6, then you could divide both sides by that and it'd just go away. You just have this thing equals 0. If it were an x, then at something x, then that would be one solution, and then you'd have this as another solution. See, if I had x times x squared minus 14x plus 19 as a common factor, then what equals 0? Then I would I'd have x equals 0, or x squared minus 14x plus 19 equals 0. So this would be one solution, and then I'd have the two solutions that we're going to get here. Does that make sense?
Yeah.
It'd just add to the solutions if there were a variable effect. That's a good question. So now, half of the minus 14 is what? -7. So put minus 7 quantity squared. Now what do I have to do over on this side? Plus a minus 7 squared. Don't forget to do that, balancing that equation. So now I've made the left-hand side a complete square, and what is the complete square I made it? X, what? Minus 7 squared. You see, that's why I never put this as a plus 49. Because when you go down here, then you'd have to go back and figure out what it was, right? Just put minus 7 squared, and then when you go to the next step, you just put the minus 7. Does that make sense? Just don't make yourself extra work. Now this one is a minus 19, and then it's plus 49. So that's actually 30, isn't it? So this is equal to 30. Are you good with that? So now I take the principal square root of the left-hand side plus or minus the square root on the right-hand side. The left-hand side is x minus 7. Everyone good with it? Now that right-hand side, when you do the square root of 30, 30 is 2 times 5, let's see, 3 times 2 times 5, isn't it? There's nothing comes out, that's my point. So it's plus or minus the square root of 30. So x, you move the 7 over, positive 7 plus or minus the square root of 30. And that would be your answer. Is this making sense? Can you? What I'm trying to do is say, put you in the position where you are working problems on a test or in some kind of a situation, and how would you approach it? Now, what would you do with this thing? You might be tempted to say, well, I got that squared on the left. Can I just utilize it? You can't, can you? You see, if there were a constant 10 on the other side, you'd be good with going complete in the square. But you got that variable over there. So you're forced to do what? Expand the thing, get 0 by itself. That's what you're forced to do. So you expand this. This is y squared, and it's a complete square. So this is 2 times, so this is a minus 6y plus 9, right? Equals 2y plus 10. Now we got to get 0 on the right, so we're going to go y squared. The 2y comes over as a negative, so it's a minus 8y. 10 comes over as a negative, so it's a minus 1 equals 0. you know, what your mind might tell you you'd like to do would be wrong, right? You'd like to try and shorten this up, but you can't. So this one is a trinomial, not a special case, and it's not factorable, is it? By trial and error. So it's a completing the square problem. I want you in all problems to do anything but completing the square, if you can. Because I'm not going to say you've got to complete the square of this problem. I think that's ridiculous. So now what's the first step?
It's plus 4 squared.
Okay, plus, and what kind of a 4? Negative 4, right? Squared. And then we add the negative 4 squared. So my left-hand side is what? Y minus 4, the quantity squared. And my right-hand side, that minus 4 squared is going to be a plus 16, plus 1 is 17, right? And now we go principal square root left, plus or minus the square root on the right. And the left is y minus 4 equals, now the square root of 17, there's nothing comes out, right? So it's still just the square root of 17. Now we take our 4 over, 4 plus or minus square root of 17. And there's your answer. You can only get it by using completing the square quadratic equation. Okay, everyone understand? The final. The first test, I took 10 problems. I changed the numbers so the answers are different. But there's 10 those kind of problems. So when you study those problems on that test and know how to do the process. Because all I've done is change numbers. Then on the second test, I took 10 off of it. I think I took 11 off there. That's the same process. And then the last 10 or 11 problems are going to come from 10-1 and 10-2 odds, just like I've always done. Any question?
You don't have to
Suggest